Welcome everyone to Pivotal Stats, where we talk about data analysis techniques, business intelligence platforms, and much more. So, let's go! Hey everyone, welcome back to another video. In the last video, we spoke about two most important libraries which are required for data analysis in Python, which were NUMPY and Pandas. Now we're going to take one step further from there and explore the details about NUMPY. If you are into data analysis or data science, NUMPY is one of the crucial libraries that you should master. Today we're going to cover a couple of basic stuff that you should be aware of before you start working with NUMPY. NUMPY stands for Numerical Python. Now, why is NUMPY important? The shining star within NUMPY is its capability to work with arrays and create n-dimensional arrays. In NUMPY, it is known as ndarrays. Now, what is an n-dimensional array? Now, for you to understand this, you need to recall your knowledge from your school days and recall what was linear algebra. When we talk about arrays, it is just a collection of values stored in a sequence. However, there are a couple of types of arrays that are there. An array can have multiple dimensions. So for example, a zero-dimension array means it's just a single point. So let's say you have a value 5 inside an array, that would be a single point array or a zero-dimension array. Now, a zero-dimension array is also known as a scalar value because it contains only one value in it. Now moving on, next is one-dimensional array. Now when you talk about one-dimensional array, values will be stacked on top of each other, and in pure mathematical terms, it is also known as vectors. Then you have a two-dimensional array, wherein you have a collection of one-dimensional arrays clubbed together. Now these are also known as matrices. Now finally, when you club all these matrices together, then that is a three-dimensional array, which is also known as a tensor. Now these concepts are very important in data analytics and data science because this is crucial when you are building your algorithms and working on complex data sets or even image recognition. Just by looking at it, these array structures are similar to a list of Python. So why is this NUMPY library required, and why don't we just simply use Python list or tuples or dictionaries? The entire reason is performance. While crunching numbers using NUMPY, the performance will be much higher. Another important factor here is NUMPY supports vectorization. Now what do I mean by vectorization? For example, you have a list of values and you want to add a certain number to all the items within that list. A normal Python list will not be able to do that. But if you do the same action inside a NUMPY library, it is certainly possible. So let's say you have 4 elements in a matrix and you want to add 5 to each of those elements, then it is certainly possible using NUMPY. For now, I think this is enough for you to give you a head start. Now let's quickly jump into our Colab notebook and see how we can use NUMPY in daily operations for crunching data. So if you remember from my last video, in order for you to use NUMPY, you would have to first install a NUMPY by using pip install. And once the library is installed, you need to import that library onto your notebook using import NUMPY as MP. Okay, so I'm going to run this. Now the first thing that we're going to cover here is how to create an array, because array is the most important part of NUMPY. Now let's see how we can create a random array within NUMPY. So all you have to do is you have to give it a name. Let's say AR equal to np.random.rand, and inside the parenthesis you need to enter the dimension of the array that you would want. Let's say I want a random array with 2 by 3 dimensions, which means 2 rows and 3 columns. So what I'm going to do is I'm going to simply write 2, 3 and run it. And if I check the value of AR here, if you see, it has created a matrix with dimension 2 by 3, which means 2 rows and 3 columns, and it has random numbers in it. Now here we have created only one matrix. Now let's increase the number of matrices that we have and create a tensor. For that, I'm going to use another number before my dimension. So let's say I want 3 matrices to be created with a dimension of 2 by 3. So as you see, it has created 3 matrices, each one having the dimension of 2 rows and 3 columns. Moving on, you've seen how we can create a random array. Let's see how we can create a custom array. So to create a custom array, let's say AR1 is equal to, I'm going to write np.array, and within parenthesis, I'm going to insert a square bracket, and within those square bracket, I'm going to say 2, 3. And if I check the value of AR1 now, it has created an array for me in a 1x2 dimension. Now let's create an array with a dimension of 2x2. So I'm going to create AR2 is equal to np.array. Within parentheses, I'm going to insert a square bracket and I'm going to say 2, 3. And after the square bracket, I'm going to enter a comma again and enter another square bracket. And within this, I'm going to say 4, 2. And the entire thing, I'm going to enclose it inside another square bracket. Okay. And let's check the value of AR2 as well. Now, if you see, it has created a matrix for me with dimension of 2x2. Now, once you've created your matrix, it is important to read them as well, right? And there are multiple functions helping you to know a couple of features or attributes about your array. Okay, the first one is to check the type of data structure that we have here. So we have created a couple of arrays, AR1, AR and AR2. Now I want to check the data type of that data structure. So what I have to do is I want to write type AR2, and when I type this, it's going to tell me it's a ndarray data type. Now what if I want to check the data type of the items that we have in this matrix? For that, I'm going to write AR2.dtype, and it's going to tell me all the values here are int64. We can also check the shape of a particular array. So AR2.shape will give me 2x2, which we already know that the dimension of that array was 2x2. And if you want to check the number of items that we have in a particular array, or simply put the size of the array, we can write AR2.size. AR2 being the array that we created, and .size is the attribute that we're going to check for AR2. Now it's indicating it has 4 items, which we already know. The next thing that we're going to cover is called slicing. Now this is similar to what we have seen earlier in our normal Python introduction course. We're going to use indexing method to slice any value. So let's say you want to check the first row of the AR2 array that we created. So what you can do is you can just write AR2 square bracket and 0, because the indexing in Python always starts with 0. So I'm going to run this and it's going to give me 2, 3, which is obviously the first row that we have in AR2. Then let's say you want to check the last item. So what you can do is AR2 square bracket and -1. -1 reverses the operation and it's going to fetch me the last row in that particular array. Now there are a couple of important math functions that are there in NUMPY. So let's create a new array, AR3, and I'm going to say np.array, and within square bracket I'm going to say 3, 8, and I'm going to enter another sequence here. So 7, 5. Okay, and close it with a square bracket. Now I have two arrays. One is AR2 and second one is AR3. I'm going to use my first math function, which is addition. So I'm going to say np.add, and I'm going to add AR2 and AR3 together. Now when I run this, it has added all the elements from AR2 and AR3 together. The second operation is subtract. So I'm going to say np.subtract and open up, and the same way I'm going to say AR2, AR3 and run this. It's going to subtract each item of AR2 and with AR3. Then we have divide, then multiply, and finally dot product. Now dot product is nothing but the multiplication of each item and then summing up the values together. So np dot and then AR2, AR3. Now if you remember, in the beginning of the video I told you that NUMPY supports vectorization. Now this is how we put it into action. So let's say I have the array here AR3, which has these values in it. If I want to add 5 to each item, I can do that doing this, and the final result will have 5 added to each item of AR3. You can also identify the square root of a number using NUMPY. So I'm going to say np.sqrt, which stands for square root, and then I want to find the square root of 81. So it's going to give me the result. I can also find out the square root of an array. So square root AR3 and it's going to give me the square root of each and every item. Similarly, I can also identify the power of certain numbers. So let's say np.power. Let's say I want to find out 12 to the power of 4. So we can write it like this. And also we can identify the power of each array item. So AR3 to the power of 2. So it's going to apply that power to each item within the AR3. Then finally, once you have your data, you might want to sort your data as well. So this is how you sort any array or number within NumPy. So np.sort, and you're going to enter an array. So I'm going to say AR3, and it's going to sort in an ascending manner. Let's say you want to sort this in a descending manner. So you're going to just say np.sort AR3, and then within square bracket, you're gonna say :-1. So if you see, the order has been reversed here. Just a quick note, the indexing here simply is stating that the first section of this indexing is for start, then after the colon it is for the stop, and then afterwards it's for the step. Okay, so when I say -1, we are just reversing the stepping order, and we have not given any start and stop. That's why it has taken the sorting from back till the front. Finally, now let's look at how we can delete a certain row or column from your data. So let's write AR3 once again so that we can get the value here. Now, in order to delete any item or element from your array, you need to write np.delete, and within brackets, I'm going to write the array name. So array3, and after bracket, there are two parameters. I'm going to enter the parameters first and explain what it is. 0 axis is equal to 0. Now what this is doing is, it's going to delete the first row from my array. So ideally the output should be 7 and 5. Now if I explain it to you, 0 is nothing but an element. Basically it's signifying the first element, and if I write 1 here, it's going to signify the second element. The axis here defines whether you want to delete a row or a column. 0 means row and 1 means column. Okay. Now when I run this code here, it's going to delete the second row from my data. So the output should be 3, 8. Similarly, if I change the axis section here to 1, which means now I want to delete the column. Now what this is going to do is, this is going to delete the second column from my data, which is 8 and 5, and the output should be 3 and 7. Okay. So if I run this, it's giving me 3 and 7. Similarly, if I change this to 0, this is going to give me 8 and 5. So this is some basic methods and functions that you will have to use for certain data analysis purposes. I would suggest you to practice this and let me know in the comment section if you have any doubts. I'll be happy to help you out. And for now, I'm going to end this video. Next, we're going to cover another important library for analyzing data within Python, which is known as pandas. So stay tuned for that. If you're liking my content, then please consider subscribing to the channel and hit that notification bell icon so that you do not miss any content that I upload. And as always, thank you so much for watching. I'll see you in the next one.